Alright, so now that I know that I have a linear transformation, I know that I can represent this by a matrix. So I'm given a basis for the domain, t squared t1, and a basis for the codomain. Alright, so these are the standard bases that we've been using in class. And so we want to find the matrix representation for this. Okay, so in general, how does this work? I have a basis x for the domain, and in this case it's a three-dimensional domain, so I have three basis vectors. The way I make the matrix that takes representation from x coordinates to representation in y coordinates is I'm going to take t of each of the basis vectors in the domain and express them in y coordinates. And I'm going to put those in as columns. So each column here is going to be the matrix representation of the image of each of these basis vectors. So it's important that we keep the order intact. Okay, so let's take t of t squared. That's our first basis vector here. And I look at my formula. I have 1t squared, 0 t's plus 0. Alright, so that means that I have 1 plus 0, 1 plus 0 plus 0. So t of t squared is 1, 1, 1. And now what I want to do is write that in terms of these three vectors. Okay, but these are the standard basis vectors in R3. So there's no work to do at this point. This is the same coordinate representation that we normally have. Now I take t of t. So that's 0t squared, 1t, 0. So 0, 1, 1 is what I get out of that. And if I express that as a linear combination of those three vectors, I'm going to get the coordinate representation to be 0, 1, 1. No surprises there. And finally, I take t of 1, my last basis vector, and that's 0t squared plus 0t plus 1. So I get 0, 0, 1, which once again is exactly the same as its coordinate representation with y. So what's this tell me? The matrix representation for this linear transformation using the basis x for the domain and y for the codomain is 1, 1, 1, 0, 1, 1, 0, 0, 1. Now how am I going to check that answer? Okay, so how do I check that this is the correct matrix representation? Well, I take a generic element of P2, express it in x coordinates, multiply by this matrix, and see that that's my answer expressed in y coordinates. So if I take a generic element of P2, at squared plus bt plus c, and I express it in x coordinates, I get the column A, B, C. So what do I get? If I take 1, 1, 1, 0, 1, 1, 0, 0, 1, and multiply that by A, B, C. Let's see what I get. Row times column gives me A. Second row times column gives me A plus B. Third row, A plus B plus C. And as we mentioned before, since this is the standard basis of R3, this is the same as the coordinate representation of this vector using y. So I took the x coordinate representation of this generic element of P2, multiplied by this matrix, and got the y coordinate representation of the image. So that means it's doing its job.